Also, Eric, can you confirm my nini iko sawa? Audio, visual, screen, recording, like everything is okay.
Yeah.
Okay, so I think 2 Thursdays ago, last week, but one probably, we had a mock interview, yeah, system design, and none of you got hired. Okay, not the word to put in. Like, I realized it was something new, so yeah, leo tumeamua tukiwa na like a system design session where we can cover the concepts, the basic and everything, yeah, so that we can have a start from there. So this will be system design 101. Niseme tu system design 101. Yeah, so okay, so system design basically, okay, the way I'll put it, now AI is here. Kila mtu anatumia AI to do something. Most of the people are using AI to do something. And it's not a bad thing actually, because AI is productive. Inasaidia wasi they ship things faster. But understanding systems is one of the key things that ziko important in tech. Understanding how a system can scale. Unaweza vibe code an app, but itafika point you're now trying to handle over 1,000 requests per second, and utapata hapo itapiga chenga kifulani. So we're going to handle this the interview way, and yeah, tutaanza tu from scratch, starting small. That's always the goal. Always start small. Just try to think small, alafu enda ukithink big later on. Yeah, so we'll tutaanza tu na the foundation, the core of all you need. Actually, sitasema hii session ni mpya because I think we've covered most of the stuff so far. Yeah, but ni ile just to get a more deep understanding. So I think niko na some nini hapa, some things tulikuwa tumecover kitambo. I'll just use them again. I'm trying to zoom out, zoom in, hata nimepotea. Yeah. So I guess, yeah, kitambo we had this thing here. Oh, let me just create a channel from scratch. Yeah, let's start from scratch. So I want us to sort of design a system. Yeah, nataka to design a system. And tunaweza anza na kitu kama, can someone give me an example of a system that we can design? An example, whether it's an e-commerce, kama it's a blog website. Just think of a silly or a complex system that you want us to design, but it's quite complex sana. Yeah, any volunteer to give us an example yenye tunaweza tumia hapo? Anyone? Any ideas? Kwa chat, or you can unmute to just to nini. Okay, we're going to build, okay, to design various systems along the way. Because, yeah, in an interview, an example, you just design any system. Every system has their own way of functioning. Yeah, an example is, assume mambo you design Uber. Uber is all about real-time communication. If you're told to design WhatsApp, hapo ni story ya end-to-end encryption. Kama umember you design nini inaitwaje? You design something like Spotify, hapo watatest like how reliable your system can be with high traffic and all that. So it depends on the type of system. So tunaweza anza small with, let's do a blog website at first. Yeah, let's do a blog website. Ama a news website. News itakuwa poa. So you want to build a news website. Right now, okay, we'll just come, tutaandika our code. Let me look for nini ya code. So, okay, let me just get a random nini. So right now, if we're to design this system, tutachukua like, tutaandika the code ya the backend and everything, the front end, hizo vitu zote. and maybe we push it to GitHub, set up a CI/CD pipeline, and itakuwa ina push that code directly to, yeah, we can have our server hapa hivi. We can push that code at any database, not a server. So tunaweza nini, you can have a database that is storing our nini. So for the database, this is where all that data will be stored. Okay, let me keep it simple for now. Let's just say we have a server and a client so that we can see how communication works. So we have a server. Remember, a server is the device that is providing, provide responses. And then this is where, let's say, your code is hosted and all that, like everything. And then you also have a client. Laptop. Juma na search laptop haikuji, but anyway. So we have our laptop. So this is our client, and that's our server. And yeah, we have a user. So tuko na user hapa. So this user is called Eric. So we have Eric hapa hivi. Eric is one of our users, and ndio laptop yake. So what you want to do, to provide your stuff in use, and we just want people to access. We want people to get access to our what? Yeah, to our news articles and all that. But there's no of the client, Eric, and our server wanaweza communicate, and this is where the concept of an API comes in. So remember, an API is a set of rules that allows communication from a server. It's a set of rules, some protocols that allows for communication from a server to a client. So from a client to a server, hapo itakuwa like a request. Maybe Eric atakuwa ameenda create a request that they want to get some 1, 2, 3, and our server will return a response. Our server will return a response. So that's the API, and that's just the high level architecture of how the communication works. API is basically application programming interface. Kenye tu ina provide ni just the nini. So how exactly do we pull this off? How do we have our nini? Doing just the client server communication, but how exactly does an API work? So kwa API, remember, an API is just a set of rules, and those rules, okay, kuna a variety of them, but I think we'll just talk about 3. So okay, if font iko kubwa sana, how do I reduce it? Small. Yeah, so for the set of rules, I'll put medium. So the first thing tunakuanga nayo, that it's REST. REST is one of the common ways to design an API. REST. So for REST, this is basically representational state transfer. Representational state transfer. You know the spelling of transfer. And how exactly it works, we organize everything around resources. So whatever you want to ask for, it's a resource. So in this case, because this is a news website, some of the resources in tutakuwa nayo ni kitu kama users, like who are the users in our website, something else like posts and comments. So these are the resources. Alafu the method of communication inakuanga mostly HTTPS. It's mostly HTTPS, the protocol being used. Alafu we also have methods. So some of the methods ni kitu kama post. Post, this is like nataka ku create like a news article or something. Then get, this is the request that is made if I want to get something. So mostly methods zinakuanga tu verbs. And then we have put. Put inakuanga if I want to update a whole content. Alafu patch is if I want to update a specific content. And lastly, delete. Delete just deletes an article. So how this works, for nini? So actually REST APIs are the industry standards, and they help us to build easy to understand. They help us to build easy, and it's easy. They help us to build APIs. How the fuck am I saying? Yeah, they help us to build. They're easy to understand, easy to build, and also it works mostly unapata the things that most the clients who use it need mobile and web browsers. Yeah, so in this case, if we were to design our nini, we can start with REST API. So there's something known as an endpoint. Endpoint is that specific part that you want to hit. So in this case, let's say we want to publish a post. We want to publish a post. Tunaweza kuwa na like a specific endpoint. Inaweza kuwa maybe, let's say our API tunaweza kuwa tumehost kwa API dot maybe hacklabsnews.com. This is where we can decide to host our API. So we'll require to have specific endpoints. So the endpoints inaweza kuwa /v1 alafu maybe /posts. So inaweza kuwa the API that is in charge of, the endpoint that is in charge of posts. So in this case, I can make like a post request here hapa, a post request, and then the body inaweza kuwa inakaa kitu kama hii. So it can be asking for something like a user ID. Most probably it's inakuanga in JSON format. So which user has made the request? Another thing, the content, like what has the user said, and then close it. So inaweza kuwa like what's in the body. And then if I want to like fetch the feed, I can naweza tumia to the same endpoint, nikuje tu sasa niongeze something like, okay, so the endpoint inaweza kuwa tu kama v1 / let's say feed, and it will be returning like a payload data. So in this case, inaweza return a post ID, the ID of a specific post, user ID, and the content. So that's a REST. It's actually the most common industry standard, and a lot of people use it. But now, utapata hapa, I'll require to have like a lot of endpoints. I'll use an example of, let's go to Daraja. And then nimeona kuna watu walikuwa na request to have a session on Daraja APIs. We'll plan that. So let's look at some of the endpoints, some of the APIs that you unaweza tumia when you're in Daraja. So unapata we have an endpoint for authorization. You first of all have to authorize kupata the tokens and everything. That's one of the endpoints that you unatumia. And then once you've gotten that, you might need an endpoint for kitu kama M-Pesa Express, basically to ile STK push, like if a user ameweka number. So hapo inaweza kuwa like part of, let's say, so inaweza kuwa part of the body, maybe the phone number and stuff. So once a user ameweka the phone number, it will make a post request to that specific endpoint. Nakwanga kwa simulate. Inaweza kuja, okay, you can look at the request body. So the request body can like a lot of maybe the callback URL, the phone number. Once the request has been made, data letter like an STK push on your phone, unaweka pin, and in a return like a response in the same JSON format. Kama response code is 0 means that was successful, and everything was and then a callback URL, hizo vitu zote. In case maybe you're using something like a C2B, the customer to business endpoint. In short, all these are endpoints within Safaricom Daraja API. So for C2B inakuanga tu ile ya customer to business. In case taki STK push or I want to work offline, maybe tuseme tu nimepatia mse my pay bill. So I want to like tell the app, umse akiweka the pay bill, should I accept the money or reject? Mostly unapatanga in vitu kama subscription, kama ni kitu kama wifi unalipa. You don't have to like make an STK push. Once umelipa to the amount, itaenda hit this you hit that endpoint, and then it will be like, oh, Alex, by the way, amelipa the nini, let me now activate their account or something like that. So these are the various endpoints. So in the second, let me close it. So in the second type of API, tunakuanga na GraphQL. So GraphQL, how it works, instead of having multiple endpoints, kama venye REST inakuanga, we only have one endpoint, and it's usually a /GraphQL. GraphQL. It's usually a GraphQL. Like you're to just one endpoint. So a client make a request asking for exactly what they want. So let's say you have like a complex nested data, alafu unataka ku avoid overfetching. Overfetching is getting more data than you need. Ama if you want to avoid underfetching, that is if you want to avoid making multiple API calls to get all that data, this will work for you because it's much simple. Unapata like the data that is coming, it's already nested into one mini. it's already nested into one utapata, like the JSON already has all that information. So you just make one API call to it only has one endpoint. When I make one API call and you get all the data that you need. So I mean you get the specific data that you need, which is good. And then I think this is the last one, the gRPC. So gRPC is basically Google remote procedure calls. Inatumianga protocol buffers. So instead of, let's say, using unaona hapa venye tunatumia text like JSON and stuff, hii inatumianga binary format. So I'll explain it in a few, the whole protocol buffers. So it runs on HTTP version 2. The others are running on HTTP 1.1, I guess. So for gRPC, we run on HTTP version 2, and it's incredibly fast. So mostly inatumikanga in microservices. Microservices is the architecture where ukona like different services running independently. Assume it's an e-commerce website. Staki like could build a whole and one repository for the whole e-commerce. Naweza kuwa na like a repository handling payments. I can have a different repository handling kitu kama catalog. So every nini runs separately. I'll need like a way for these services to talk to each other, and this is all about Google will create the gRPC so that the nini can communicate. So how it usually is, what una register a certain nini. We usually register, how do we call it? What una register like how the data will be stored. So this is how protocol buffers work. So let's say maybe in our database tukona, okay, let's say we have a JSON file, ikona kitu kama name, and then the name can be something like Alex, and then the age can be something like 21. So instead of every time I want to send this request, maybe nataka I want to like make a payment, instead of sasa make this request directly to the other microservice, I'm wasting a lot of bytes kutuma like all this data. Remember that an integer, I think integer unapatanga, okay, not integer. Yeah, an integer inakwanga na very, mnakumbuka data types. Every data type has their own amount of bytes. And if you send like a lot of bytes, first of all, itakuwa much slower. And this is where protocol buffers come in. So you just define like a .proto file. Inakwanga like a certain .proto file, and you put it in both services. Alafu hapa na create like some sort of a schema. So the schema hapa inaweza kuwa kitu kama message user. So the schema inaweza kuwa kitu kama hii. And then after I just define like I have a string called name. I'll give it the value of 1. And I have like let's say int 32, which niweke chini, and then the age is equals to 2. So both services, both microservices, it understand the data because I've configured them. So the numbers will act as filtered. So if I send a request like I want 1, so when gRPC sends this data, itatumia like the name and the age. So itatuma like the binary package that says maybe field 1 maybe ni Alice, field 2 ni 30, which makes it even faster. So the reason it's fast is because of the binary serialization. That means converting the data to binary and back. It's usually fast for the CPU chips, and also the payload size is much slower than sending the whole JSON file. And also the fact that we are using HTTP2, yeah, in allow for multiplexing. Multiplexing is sending many requests over a single connection at once, and also bidirectional streaming. Yeah, so that's gRPC, and that's how the name works in Italy. That's how APIs work. Kuna swali before we move on to the next concept? Any question? Kuna mtu amepotea anyway? Okay, I'll proceed. So yeah, shall know how APIs work, but we have to save hizi posts zetu to like nini inaitwaje? Okay, how will I put this? We have to, okay, where does this data go? Hii data yenye tunashinda tume request inatoka wapi? The response that we are, I mean the request that we are making, where does it go to? And the response that we are getting, where does it come from? And this is where a database comes in. Okay, when I needed it the most, ilipotea. Nani ameona database yangu hapa hivi? Where's our database? Okay, let me just utilize the search function, which does never helps kabisa. Oh, ndo hii hapa. So this is where, but then inapanga database kweli. Yeah, inakaa database. So let's just say it's a database. So this is where, because okay, our server is receiving nini. Let's say nimeenda nika publish a new article. Let me just call them articles. A new news. Okay, articles. So let's say I want to nataka kuweka nini. Where is this data stored? Basically it's stored in nini inaitwaje? Okay, if you want to store them directly kwa the server inakuanga pia na its own memory. It's like I mean the RAM, which is temporary memory, it will disappear every time you like start the server, if the server crashes it will disappear. So to prevent this is where we need a database or ina persist the data. So we usually have two database families. For database families to connect the relational, let's go to that. So we usually have the relational database, or we just call them SQL. We also have and we also have non-relational, also known as NoSQL. So what's the difference between a relational and a non-relational database? So first of all, this is how a database would look like. Sijui kama kuna nini ya tables. Do you have like a table? Let's use the film tool. So this is our film tool. Can I get up? So it could be designed to, hey, sorry. It could design to work as, so you know how a pen works. I mean, how a Excel works. You know how an Excel works. Excel spreadsheet, Google Docs. Frame yangu imepotea. Let's use the box. Missing your frame. Can anyone see this? The box here. Here. How much should I add some? Kuna mse ameunmute. Martin. Okay, Martin, maybe you can mute. So when your data is stored, let's say this is our database. Zinakwanga stored mostly as a table. So it's basically a table actually. Mbona kitu iandiki? Jeez. Nimeshindwa kuchora. So let's see how spreadsheet inakaanga hapa hivi. So let's get a blank spreadsheet. So hivi ndo mnajua venye Excel inakaanga. So we basically have a table. Hii table inaweza kuwa na kitu kama user ID. I mean that's a column. Column iko na like user ID. Okay, let me close Gemini for now. We can have something else like articles. Maybe this can be an array of articles, probably kituka hiyo. We can have the date created, date modified. Yeah, just hivyo tu ninakanga. So for user ID we can have user 1, we can have user 2, can have user 3. Okay, nisijui kutumia Excel actually, so but get how a database looks like. So unaweza kuwa na like multiple tables. Let's create a custom. Na sijui mbona my biro isn't working. Mashine imeleta maji mingi. Is it opacity? Yeah, opacity ndio ilikuwa issue. Even better. Nice. Okay, so as I was saying, naweza kuwa hapa na my database, my table that is. So hii table yangu nitaita users. I can have another table called, which other table can I have? I can have another table called articles. So this is for a relational database. So this can be articles. And yeah, articles. And also, okay, so for the users, tunaweza kuwa na like different parts, ama different columns, whatever. So tuzichore tu hivyo. So one of the columns, hapa inaweza kuwa for user, it requires a name. Okay, so this is basically a schema. So a user will require a name. They'll need an ID. They'll need also probably articles. And they'll need nini ingine. What else does a user require? Tuseme kitu kama, yeah, tuseme likes. And then for articles, we can have different data here. So these are the tables. So an article can have an article ID. The article can have an ID. Itakuwa pia na like a user ID probably. And this will be a foreign key ama. So this one will be mapped to the ID of the user. So in case I want to need this article, it belongs to that user. And then, yeah, it will require to have a content. It needs like a date. Yeah, tuseme tu niyo for now. So unapata this is how mostly a relational database is, because yeah, it's relational, like zina relate pia. So for relational databases, we usually use a language known as SQL to manipulate and query the data. So in this case, let's say I want to get like all the articles that belong to this user. I can use an like select all from articles. So I want to get all the articles where maybe user ID is equal to 1. Kitu just like a simple to command, and itamletea like all the articles that belong to a user with user ID 1. So unapata SQL is the language that is used for nini? SQL is the language, structured query language. It's the language that is used to manipulate data in relational databases. So some of the relational databases utapata huko nje, examples include MySQL, PostgreSQL. Yeah, so they store data in structured tables. When we have like a structured tables. In short, we have a row, we have a column, and also a predefined schema. So what we've done right now, this is actually just a schema. So nakuja nasema maybe the name itakuwa like a character, ID will be like an integer, articles will be an array, likes itakuwa an integer, and also we use relationships. So in this case hapa tumeka like a foreign key, because these are two different tables, and yeah, we have the relationship there. And also an important factor to consider is the fact that zinakuanga na his stuff, acid. So acid is basically, it's a how do we call it? Not a feature, it's a, okay, nimesahau the nini. So acid is an acronym standing for atomicity, consistency, we also have isolation, and durability. So what exactly is atomicity? Atomicity, there's this concept of all or nothing. So in case an entire transaction is succeed, I mean either the transaction, a transaction is basically an operation that occurs in let's say it's a financial system like an M-Pesa. So either the whole transaction is succeed or may fail and it rolls back to how it was. So an example, tuseme nimetumia Eric 100, si ndio? The database should deduct 100 from my account na add 100 kwa account ya Eric. So in case the database ita crash halfway, the first transaction that I've made should be cancelled, because remember we have two transactions. The first one ni the operation where account yangu lazima ikuwe deducted, and the second one ya Eric lazima iongezwe. So in case nishafanya the whole alafu database crash, the first transaction shouldn't take place. Inafaa ikuwe cancelled. So that's atomicity, all or nothing. So the second one we have is consistency. So consistency is like one transaction inafaa bring the database from some sort of a valid state to another, like to maintain all the predefined rules zenye tulikuwa tusha set earlier. So this is like a constraint. Assume account yangu iko na 0 bob, alafu na try maybe kutumia Eric 100, inafaa decline because it should, like, the state should work immediately. Yeah, haifai ati sijui maybe after nishatuma do, maybe the balance haija reflect immediately. It should be consistent. And then you have isolation. Isolation is just self-explanatory, like everything is isolated. So an example of this is if two people wanataka ku withdraw, okay, tuseme mimi niko na bibi yangu, we have a family account na tuko na so pekee, and we want to withdraw hiyo so at the same time. Unaona, like we try to do it at the same time. So isolation ensures that both don't succeed. So itakataa all the transactions. And this is something that unaweza pata like in a question, most probably in an interview unaweza ulizwa like how do you handle a situation where two people make a transaction at the same time. So the whole concept of acid compliance when ina apply hapa. And then durability is just keeping the durability. It's basically keeping a transaction permanent. So ata like steaming ikipotea, the data won't be lost. Everything should be there. So that's the the advantage of using a relational database. So for the ACID compliance, it's critical mostly in financial applications. Yeah, because you can't afford to lose track of money. Plus also compliance in case maybe you're running a financial service. Our system, obviously there are compliance rules that you must follow. Assume wakuje kuitisha your audit logs and stuff. You need to make sure that everything is logged, and and also so that will work. So remember examples in Postgres and MySQL. And I guess next tunaweza enda into non-relational database. So for non-relational database, in SQL, so they usually store data as documents. So the documents can be the documents inaweza kuwa the documents can either be JSON, inaweza kuwa ni key value pairs. They can be key value pairs. Also zinaweza kuwa graphs. So hazinanga like some sort of a schema, which means you can change the data without altering like the structure. Na kama hapa we have a schema. So for non-relational database, they don't have a schema. Alafu they usually hazina like any relationship, so it's also easy to scale horizontally. I will talk about horizontal scaling later on. Much easier than an SQL database, and that's one of that's one of the advantages. So what do you mean when you say tuna store data as documents? So hapa naweza kuwa nimesema we just want to store the data ikiwa like a key value pair. Okay, so for the key value pair, this is where ndasema I need to have the name of this person. So name Alex. This can be stored as a JSON or whatever. So name Alex. Another thing can be what's his age. The age itakuwa ni 20 and that's it. I don't expect nini itumike anywhere else. So it's been stored as a document. Also an example is Firestore. I think we can look at an example. Isikiwa mnaona ni Java hapo hivyo. So let's look at an example of Firestore, which is one of the most common used. Ni nini ina user data hapa? Sitaki ku yeah, let's use tawitaries. Sijui kama niko na data kwa Firestore. So unapata this is how it looks like. Normally, okay, hapa I can have a collection. A collection is just what I expect. So this can be like a menu item, and this is the document. So unapata everything is stored as a document. This first nini isn't related to the second one in any way. Kila kitu iko independent. So assume in kama tu admission number yako. I don't expect that tutakuwa na nini. So for this, unapata this is one of the documents and in the data yake, it's a key value pair. The image URL and the image of that nini. Is it out of stock? That's a boolean, true or false. What's the name? Name ni minute maid. Is it out of stock? Maybe true. Price 80. Key value pair. There's nothing more. And it's not related to this other table in any way. Like everything is just separate. And that's what we mean by no SQL. Yeah. Any question hapo kwa database? Anyone? Ama kuna concept hamjaelewa? So that's one of the examples. We have Firestore, kuna MongoDB, we have Cassandra, we have DynamoDB. Yeah. So hapo inakuanga like a choice because remember this is system design. You'll know like what fits the design that unataka kuweka. In case you will feel like, okay, this is the data that I'll be requiring and this data will depend on this, I'll have to use a relational. So these are some of the factors to consider before starting even to code and all that. So yeah, that's it about the database. So we've already built our system. It's working. We have our front end, we have our back end, we have our whatever. So let's try to we put it together where we maybe our news website imeenda live. We've been posting some good content. People love our content. And right now we are dealing with kitambo. We just had Eric as our user. And right now tunaanza kudeal na over sijui ni ngapi, but let me try to distribute it. So let's say right now we are dealing with 1,000 more Erics. So this is where the issue of copy paste mara ngapi. This is where the issue of scaling comes in. So always consider peer scaling in case I thought copy paste once. Let's keep on to wameisha. So tuko na Eric, let's say we have 1,000 Erics. So hii server yetu ilikuanga na let's say 1 GB of storage, not 1 GB of storage, 1 GB RAM, and then maybe 25 GB of storage. So right now, the fact that we have a lot of requests being made at the same time, tunafaa to expect some things happening. So the first one is the CPU. The CPU will spike, like the utilization will spike, like kutaanza kuwa na unaona venye laptop ya Ellen inakuanga when you run a lot of programs at the same time, inaanza ku overheat and yeah, so we might expect that in our system. Itaanza ku overheat, which will make it slow. And also the memory itakuwa full and it might cause the server could throw in server errors like the gateway timeout, which is a 504 error. So that's one of the disadvantages. And how exactly do we scale? So site kwa scaling as another concept in system design. So in scaling, tunakwanga na two ways of scaling. The first one, let's scale it vertically. So tuko na vertical scaling. Other people wanasemanga also I'm scaling up. So scaling up, I'm a scale up. So what I'll do, basically I'll just take my server currently, niongeze resources juu. Let's say ninatumia a virtual machine from Google, as enda I reprovision it. Maybe niseme I pick something with 4 GB and 500 GB, which will work. And then we keep on trending to pata like even more Eric's. We'll get more Eric's hapa hivi. So tutapata more and more in a way that hii itakuja to support vizuri. We continue scaling up again tuchukue sasa 8 and then next 2016. That's scaling up. Tuna add more resources to our existing server to make it bigger and more powerful. So we're just upgrading our physical server to have more CPU, more RAM, and faster. So this is simple. That's one of the advantages. It's simple since we don't have to change anything like code or database structure or anything. Like we're just dealing with it. So one of the disadvantages is kuna kwanga na limits. Obviously, siko sure. I think okay, maybe tunaweza pata the highest can be a 256 GB RAM ya server. Unaweza pata that's the maximum you can get. And if you can't go above that, there's nothing you can do. And also another disadvantage, having one server, it's a single point of failure, SPOF. It's a single point of failure. Assume this server yamwe kwenda down. Our site is dead completely. So it's a single point of failure because we only have one. And this is why horizontal scaling is recommended. So at number two, we have horizontal scaling. Hey, typing errors, horizontal guy. So horizontal scaling, this is scaling out. So instead of having to upgrade one server, we're just adding more servers, maybe of the same size. So I'll just take this server, I'll add another server, hapo hivyo, of the same size. Hivyo sasa. So we'll be having like separate, we are scaling horizontally. So this unaweza pata it's much cheaper because maybe zote ni za 1 GB. So the advantages is high availability. So in case that one server crashes, the other servers they'll keep on working. So the disadvantage is the complexity, like how exactly do we split traffic? Do these servers share the same database? So those are some of the complexity, some of the cons, the complexity of kuseta. So right now that we have different servers, each server ilikuanga na IP address, let's say I'll give it something like a 10, let me zoom in. So maybe ilikuanga 10.0.1.2 probably. Maybe inaweza kuwa na like okay, let me just use the same IP address. I'll just change the name, maybe equal 0.3. Alafu equal 0.4. So how do I expect the users wajue like where to go to? The fact that tumepatia different locations. So this is where the concept of load balancing comes in. So let me look for a load balancer. Yeah. So this is where the concept of load balancing comes in. So because we've chosen to go with horizontal scaling, we'll have 3 servers to manage and we'll require load balancing. So the purpose of a load balancing ina act as a traffic police. Kazi yake ni distribute the traffic. So this one will have the single IP address. So instead of a users, do you remember the whole concept of DNS? So instead of kwanza kwenda kwa different IP addresses, itakuwa na like the main IP address. So maybe this is where the nini can be. So all the users will have to go hapa hivi before they can even go elsewhere. So all the clients, these are the clients, all the Eric's will go directly to these load balancer, and then it will distribute the, how do we call it? It will distribute the traffic. So how exactly does it distribute the traffic? So this is where we have the certain algorithms. Hapa pia inakuanga a preference you can pick to choose. I'll just talk about 6 of them. So tunakuanga na like the strategies and some algorithms za load balancing. The first one inakuanga round robin. A round robin algorithm ama strategy. So how a round robin works, nilionanga hapa we have a laser pointer. Yeah. Mnaona hii laser pointing? Nice. So for a round robin ina split traffic equally. So ya kwanza ikikuja hapa, request 2 will go here, request 3 will go here, request 4 will go here, 5, 6. That's round robin algorithm. And hivyo tu, that's how it works. Ina distribute nini equally. The second one inakuanga, we want to check which one has the least connections. So assume hapa hii inakuanga na like 100 connections, iko na 50 connections, iko na 90 connections. So itakuja iangalia, okay, hii haiko busy sana, let's send most of our nini to this server. So that's another strategy of least connections. Itakuja inatuma the requests hapo because this one doesn't look busy. Another one is the least response time. This one might be responding after every maybe 20 milliseconds, 30 milliseconds, 5 milliseconds. Itakuwa like, okay, this one is faster. Tutumie huyu. So that's the least connection. We also have the IP hash. Anaweza kuwa nikiona, okay, a lot of nini requests zenye zinatoka from Eric1, like the IP address, kuna some hashing that happens. So nikiona like Eric makes a lot of requests to this server, acha tuweke tu request zake ziendange huko. There's no need of ya kukujanga huko. So it ensures like some sort of a consistency, the connection and everything. Alafu pia tuko na nini geographic algorithm. So hii server iko karibu na Kamiu, so acha watu wa Kamiu tu watakuwa served na hawa. Watu wa Kangaru they'll be served with this one. Watu wa G-Town, because this server is closer to them, they'll be served with that server. So that's the geographic algorithm. And then sasa kuna the weighted algorithm, tutacheck according to performance. Hii server yetu RAM yake ni 8 GB, hii server ni 16 GB, hii server ni maybe 1 GB. Twende tu kwa hii yenye iko na a higher weight because it will serve us more. So those are some of the nini, sijui kama nitazikumbuka. Yeah, there was round robin, kulikonga na list connections, weighted algorithm, no weighted algorithm. Yeah, IP hash. There's also, yeah, Camille. It will continue nimesahau geographic. So hapa inakuanga also a preference. You can decide my application does this, so let me use this algorithm to kufanya the load balancing. Ingine ilikuwa least response time. I know there might be more, probably, siko sure, but yeah. So let's say server yetu imoja kuja crash, like will I get any? Okay, let's say our server decides to crash. So how will the load balancer avoid sending traffic to that server that has crashed? So think of it this way. Okay, load balancer inakuanga na certain nini. So in as much as it does the traffic distribution, it carries out health checks. So health checks ni ile like it has to, inakuanga na like a certain endpoint of checking if a server is healthy. So hii server ikikosa kurespond, the load balancer itaimark as unhealthy and it will stop routing traffic hapo hivyo, and also it will replace that server. So itakuja itoe hii server iweke a healthy server. Yeah, that's how running health checks. And what if a load balancer fails? Remember kuna this concept of single point of failure. What if a load balancer fails? Considering that's our traffic police, what if it fails? So to avoid the single point of failure, we should have like tunafaa kutumia redundancy. So redundancy is basically having two load balancers, but one will act as a passive nini. It's mostly an active passive configuration. One load balancer itakuwa tu ina work, and this one will just be listening kama huyo ako active. So itakuwa like ina send, maybe itakuwa mostly on standby, and kazi yake ni kumonitor the heartbeat of the active load balancer. So in case maybe inini fail, the passive load balancer will act as a failover. So it will take over from there. Yeah. And that's it about the whole concept of load balancing. Inakwanga tu ya kudistribute traffic instead of server yetu kushinda ikihandle all that traffic at once. Ini itakuwa hapo. So yeah, that's okay, but also realize tunashinda tukiwear out our database, because every time tuna make a request, this server will be coming making a request to this ingine inakuja, I mean database, not server. So the server ina make a request to the database, all these SQL queries zina wear out our database. So how exactly can we solve that? So instead of having all this information being sent hapo, to introduce a concept known as caching. So for caching, you can use something like not Reddit, not Replit, Redis ama Memcache. So unaweza tumia like nini. So Redis ita cache the content. So we also have like various ways zenye, okay, so let's say nime make a request to the server. It will first of all pass through our cache, and then in case like the information is in the cache, it will return directly to the client immediately. In case haiko, okay, in case ipatikane, that's a cache hit. That's a cache hit. And in case then you need the feed ama the article is not found there, that's a cache miss. So in case kukwena like a cache miss, sasa ndo Redis itatutuma kwa the database. So we don't have to like send all the information to our database. Yeah, so Redis usually na save like a copy of the nini through a concept known as caching. Yeah, so pia the nini caching inatumianga some strategies of ensuring in a cache. So the first one is cache eviction. We usually use cache eviction. So cache eviction, any like in case our cache ran out of memory, actually nini inatumianga RAM instead of normal storage. Ina store nini for a certain nini. So RAM is limited and it's expensive. So in case our cache fill up, how will like our Redis decide which data to release and all that? So inaweza tumia like cache eviction, ini like kuachilia. It can use the Aleru. This is the least recently used. So ikiangalia like, okay, hii site ya Eric watu hawajatembelea for a long time, I'll just release it. If we use something like LFU, this is the least frequently used. Like even if it was accessed recently, maybe na msemo moja, it's not accessed frequently. So I'll just discard it. And also the concept of FIFO. FIFO is first in, first out. So ili accessiwa kitambo sana, I'll release it in order. Imeniniwa juzi. So FIFO is basically just the concept of like a queue. Huwa alikuja wa kwanza, acha atoke wa kwanza. And also we can use the caching validation. So for a caching validation, ini could prevent like old data from being in the system. So how do you prevent it? Hapa ndo tunakuangana like hapa sasa ndo tunakuangana kitu kama TTL. This is the time to leave. Naweza kuwa nimesema okay, in my nini ndakuwa na clear my cache after every 1 week. And also kitu kama caching validation. Maybe this data was already deleted from the database. So msame make request, nimeenda nikapata hata iko kwa database, so I'll just delete it. And also remember, we have one database. So one database acts as a single point of failure. So how exactly do we prevent, in case our database server it a crash, we don't want our application to stop. And this is where we have database replication. So I'll just create like a replica, a backup of our server, of our database. yeah, now create to like a replica in case maybe, okay, this is just a concept known as master slave replication. So this is the master, this is the slave. In case kukwena like a downtime in our server, then in our master, nashinda nikitumia jina server sana, in our master database, the nini the nini can take over, and also tunaweza sema maybe our master will handle all the rights. So kila msemo mwenye anakuja kuandika and all that, this is what will handle that, and maybe nini the slave ita handle all the reads. So everyone who is like trying to read, so inaweza kuwa set as read only. Anyone who is reading will be handled by the slave. So that will work. And also remember, just like when tulifanya horizontal scaling, tunaweza tumia like a concept known as database agent inapotea. There's this concept, database something, sharding ni ile we have like a lot of data. Let's say we are storing over 1 terabyte nini, na nile like the database iko just too big for that. So I can decide to like shard my database into sections. So the difference between replicating is just copy. Nasema I want to copy exactly what is here to a replica. But sharding, it's like tearing a book into 3 pages. Nasema maybe, let's say I have a dictionary, you tear into 3 pages. The first one is a contain information from A to N. So they're basically splitting the nini. The second one from O to a different letter. Sikumbuki alphabet vizuri, then T to Z. So maybe I can create a certain nini that will check kama a request belongs to this database in Endapo. So this is database sharding. And that's our system design, to design our system. And we've deployed it, everything is working, but we have another issue. So the issue is watu wa Kangaroo, they're saying that the system is slow. Watu wa Camille wanasema the system is okay with them. So that's a latency issue. So latency is the amount of time. Acha nitumie the laser torch again. I love this laser torch, laser pointer. So latency basically ni hii. That's latency. The amount of time a request inaenda to the server and back. We have to make the latency as low as possible. So unapata nini? Let's say on a map, server yetu iko shule, ndio server yetu si iko shule. Msi anaishi Bagik will get a faster response compared to msi anaishi G-Town. How will I like make wasi wa G-Town pia wa feel included in that? So hapa ndo tuko na the concept of CDN. A CDN is a content delivery network. So in short, I can just create nini. Okay, I can just create, how will I explain this vizuri? So a CDN, it's like replicating maybe the cache. Nazama replicate the cache, nieke like some sort of a small server, maybe pale G-Town. So wase wa G-Town wakibrowse, they'll just get a response directly from that cache. So that's basically what a CDN does. Like I'm just trying to replicate the nini, ama ku make the resource equal near the user. Yeah, that's CDN. That's our CDN. Yeah, and I think I'm done. Yeah, I think I'm done. Sidhani kuna kitu ingine. Oh, let me introduce another name. Nimekumbuka we have this tool known as Nginx. Nginx acts as a load balancer and also a reverse proxy. So I wanted to talk about, I think kuna logo ya Nginx. Yeah, right. So Nginx acts as a load balancer and a reverse proxy. So a reverse proxy, we don't want like nini, hatutaki, we want to hide our nini. Unaona the way you guys use a VPN, that's a forward proxy. And if you make a request to the nini, I won't know who has made that request, because yeah, you've set up a forward proxy or a VPN or whatever. Like it hides your identity from the websites. So a reverse proxy also does the same, but in reverse, in a hide our servers. It hides our servers. So I can just use my domain name, but everything else will be hidden for the reverse proxy. So think of it this way. Maybe nataka kupigia, I want to like get a plumber, si ndio? And I don't have number ya plumber hadi mmoja, but I have a company that I know and inafanya plumbing. I can just call them, alafu msi ako kwa front desk atakuja ashike simu, and they'll now be like, okay, let me refer you to someone. Naona ile ya let me acha kiasi ni ku redirect to the person. So that's the concept of reverse proxy. And we are done. That's system design. So you can apply this in like different places. Let's say umeenda ukaulizwa like an interview of how you design Spotify. Spotify unaweza kuja useme we have reads, we have writes. Let's say kama wimbo moja inaweza store like a metadata. I mean the metadata ya wimbo moja inaweza kuwa 5 kilobytes. Try to estimate, let's say have this number of artists. The artists kwa database unaweza kuwa umewekea like a foreign key because they have various number of songs. This song is related to a certain user. I mean a certain artist. I also expect to have reads. I expect to have the streaming, like say ile ati wimbo inakuja once and we have to wait or something, like ngoma tu iende consistently, like how can I create the recommendation algorithm. Yeah, it's basically ni vitu you will now try to apply the whole concept in a real world scenario. Something, a system like Uber, hiyo ni event driven architecture where like nataka real time communication where like I want to see where the driver is and the driver needs to see where I am in real time. Yeah, also kwa the networking layer, most of these menus zinakuanga in the application layer. On the networking layer kuna the concept of TCP and UDP. TCP is the inakuanga transmission control protocol or something. Yeah, where I have to like each and every byte lazima ikuwe accounted for. It's like nikuje niseme Eric aitike and I'll be like, oh, umeitika. Andika hii number 07 and then you'll be like, okay, 07, 01, 01. Like the communication to make sure everything imefika. But for something like UDP, I'll just be like Eric 0701 that 452 and nivyo. Hata kama Eric hajasikia, the data has been lost. Mostly unapatanga UDP, they use the datagram protocol. Inatumika in vitu kama live streaming because live streaming is kitu happens in real time. Na ikipotea, I can't say it is doing the rudisha nyuma or something. Yeah, and also concepts kama za WebSocket, instead of having to wait for a request to response through HTTP protocol, WebSocket ni ile tu mostly for multiplayer games, like ensure there's a bidirectional communication ama communication over TCP. So this new will do like the handshake, and yeah, inatoka from HTTP to now WebSocket. So once connected, the channels will stay open, like they'll just be communicating nini. Yeah, and also we have concepts like webhook. Webhook ni ile tu, I usually use this concept of don't call us, we'll call you. Ushaona kitu kai, instead of the client having to every time check kama nini imekuja in the server will be like, just give me your webhook URL in case hii kitu ikuje, I'll pin you, kitu kama hiyo. Yeah, so it's mostly unapata for something like a webhook, it's used for server to server communication. Yeah, and that's just the basic. I'm done. Mimi nishamaliza. Any question? Questions? Eric, unaweza niangalia YouTube if there are questions. So how do we manage the system request to the DB? In what way? Requesting system? Okay, Clarissa ndarudia part ya Nginx. Eric sija get the question vizuri.
Okay, maybe mwenye ameuliza atauliza tena. Nimepata from YouTube.
Okay. But if I try to nini? Okay, Clarison hapo kwa Nginx. Nginx is one of the tools yenye inatumika in load balancing, and it also acts as a reverse proxy. So Nginx is just a tool. So the concept of reverse proxy ni ile nimesema, unaona the way you can use a VPN to hide your identity in the internet. Let's say if I want to make a request hapa hivi, staki like mimi because I'm the one who is in the servers, Eric ataki nijue where the request has come from. They can use mostly tunaitanga it's a forward proxy because imetoka kwake. So that's the same case with our Nginx. It acts as a reverse proxy. So it just hides where the request is coming from. It hide like our server IP and all that. We can also have a separate session on Nginx tuone how to configure it on your server. Hizo vitu zote. Yeah, I'm trying to answer the question ya Craig and also Clarison at the same time. So venye nimetumia the analogy of we have like a plumbing company. Let's say I want to nataka kuwa na service ya plumbing, and see, I don't know a plumber but I know a company, so I can just call them and niwaambie hello, mnaweza kuwa na like a plumber who is near Kamil, and then they'll be like hold kidogo ni kuredirect to the nearest plumber who is in Kamil. So first of all, sijajua hata the number of that person, but I only have one number at the headquarters. So that's the concept of reverse proxy. I hope you're willing to get. Okay. Any other question? Ama mimi niulize maswali. I was trying to kuweka nini Slido, but nime realize whatever I wanted to do was a nini, but nda create a nini, tutai nini with time. What were we supposed to do? Ama naweza weka a different Slido tufanye. Yeah, last time, but then ya Linux. Okay, let me use like acha niulize basi maswali. So, okay, which service sits in front of the application servers and distribute traffic? Distribute the incoming traffic, the incoming request, client requests. So, make sure the servers don't get overwhelmed with responses, with requests, that is. Yeah, it's a load balancer. Okay. Okay, Kiasi, let me prompt Cloud inipatie maswali. Just a second. Mnaweza uliza maswali zenyu pia hapo hivyo. Yeah, nimepata. These are like riddle questions. So I'm stored entirely in fast RAM rather than slow hard drive. If you need to read the same database record 1,000 times, you should look for me first. Who am I? Redis is an example of what you're trying to mean. Redis is just an example. Remember, we have different tools for hizi vitu zote. Like something like a load balancer, unaweza tumia kitu kama, there's a load balancer in GCP. You can create also your own load balancer na using kitu kama Nginx. I'm not sure if Apache does the same thing. Alafu kwa AWS kuna kwanga na the Elastic Load Balancer, ELB. Yeah, so the answer for this is cache. Cache. Naitanga cache. Niko na joke, guys. Why did the programmer go broke? Why did the programmer go broke? Because he ran out of cash. Kwani si funny, hamcheki. Ama any nanga reactions? Okay, I'll assume it wasn't funny. Okay, the other riddle. Okay, if your single server is overwhelmed, you might buy a bigger, more expensive machine with 128 GB of RAM. Oh, this isn't a riddle, it's just a question. So if your single server is overwhelmed, you might buy a bigger, more expensive machine with 128 GB of RAM. What scaling strategy did you use? What scaling strategy did you use? Horizontal. Not really. Not really, si horizontal because nime upgrade to the nini, nime upgrade the server, sijaongezea like more servers. I've upgraded the current server that I'm having. That's nini, vertical scaling. Horizontal ni ile I'm adding nini zishare the load, but for vertical scaling ni kama niko na lapi nianze kuongezea RAM, nianze kuongezea a new SSD, hizo zote. Okay, so when a driver's GPS location changes in Uber, the phone uses me to keep a persistent open phone call connection with the server, so coordinates can stream back forth instantly. Who am I? When a driver's GPS location changes in Uber, their phone uses me to keep a persistent open call connection with the server, so coordinates can stream back and forth instantly. Who am I? Who am I? I think it's the last thing nimeongelea, the concept of nini talking at the same time. It's also a concept used in multiplayer games. When a driver's GPS signal in a change in Uber, so their phone uses me to keep a persistent open phone call connection with the server, so coordinates can stream back and forth instantly. What am I? Not really. See UDP. UDP is a protocol. User datagram protocol. Okay, choices. Kuna webhook na WebSocket. Which is it? It's not really a webhook. Webhook nimwambia ni ile nini ya nini, how do you call it? The analogy of don't call us, we'll call you. Yeah, that's a webhook. So okay, application ya webhook, I'll use an example of kitu kama WhatsApp. Naweza kuwa nimeset, let's say I have an application that I'm creating. Okay, let me use an example of kitu nishai work on. Yeah, let's say ni kitu kama WhatsApp. I want to create like an automation ya WhatsApp. So I can get like a webhook URL, and if a user any texts, the webhook itakuwa hit, and then now my application can respond. Unaona? So it's the concept of don't call us, we'll call you. Instead of me having to ping the server every time kuangalia kama kuna kitu, I can just leave my phone number. In this case, that's my webhook URL. Alafu in case maybe sasa I get a response, in case nini hiyo kitu ikuje, they'll now alert me. So in short, it's the server making the request ya kwanza. An application of webhook, I think inatumikanga in, okay, let's use nini, tutumie tu Daraja API. So how it works, if I make a request to nini, okay, let's say I have an application hapa. I have an application. This is my application. Ama tuseme it's a phone, I want to make a payment, sindio? Ama I want to subscribe to something. I'll make a request through my server. My server ita initiate a request to Daraja APIs. Alafu, once the transaction is made, the Daraja APIs ita return a response, sindio? So because we return that response, I'll need some sort of like a callback URL. So hiyo ni ile like venye nimesema. So I leave my callback URL ama my webhook URL niachie M-Pesa. So ni ile ya if this transaction goes through, you tell me. So once hiyo nini imekuja, once the response imekuja, so kuna different responses. Either the transaction has gone successfully, the user has cancelled the request, the user may enter a wrong PIN, or the user may insufficient balance, ama there's a timeout. Hiyo response itakuja now to my webhook ama my callback URL, and then I can now send it back to the front end. Niseme, oh yeah, the request was unsuccessful because of this. So that's the concept of a webhook, like tunaiacha hapo. And then our WebSocket ni ile like initiate constant communication between a client and a server, or a server and a server. Ndio zikuwe in constant communication. That's why unapatanga tunakwanga na multiplayer games, like I'm able to stream directly bila kukuwa na sijui, I have to first of all shoot and wait for hiyo kitu ya happen, and then nakuja naambia okay, this person has been killed already, like that concept. Yeah, I am done. I'm done. Nishamaliza. Any other question before watu waende? Any other question?
Kuna hiyo ya YouTube.
Increasing system data request speed from the database. Okay, Abba, I'm not sure, but for me, I'm trying to think. What am I trying to think? Okay, sijui if there's a way to like increase the speed, but pia I guess the language that you're using maybe to build your API matters. That's what I'm thinking. The language matters, because remember, a language like, okay, kuna languages zinakwanga so and a lot of abstractions juu yake. Let's say kitu kama Node.js. Unapata the response time for this language might be slower compared to another language. Maybe something like Go can be super fast and something like Node.js can be slow. That's what I'm trying to think up with. Yeah, I'm not sure if nimeget hiyo swali vizuri or nimeijibu vizuri. Tuko nini? So can we do like another mock interview next week? Nani ako ready? Nani atajitolea to give it a try? Who wants to give it a try next week? Okay, guys, have a good night. We'll meet. Okay, watu wa DevOps will meet next week for containerization. We'll cover containerization. That's Docker, Docker Compose, Docker and Docker Compose. Yeah, that's what we'll be doing next week. So have a good night, everyone.